Hello everyone. So I'm going to talk about the mini project that I did for IT6050 Big Data Analysis. I'm Sajeev Premsinghe. So first I'm going to talk about the definition of the problem. So in this particular study, we are considering a data set uh, where we have description about prediction on the quality of wine based on some physicochemical parameters. So there is a bunch of physicochemical parameters. When that physicochemical parameters are available in this data set, there is a particular value for the quality that indicates the quality of that wine. So our goal is to create machine learning models to predict this value for wine quality when we have the values for each of the physicochemical parameters. So in a way, this is a sensory evaluation study. And sensory evaluation is a really important type of analysis when it comes to food science and technology. Because whenever there is a particular, for example, especially a new food product available, when we want to evaluate how the consumers feel about that product, we usually do a sensory evaluation to get their feedback on the quality of the product. So this is a similar type of data set which contains consumer feedback in the form of a quality parameter. So in this study, I will describe creating a bunch of machine learning models which have been trained on the data that is available to give predictions on the quality of wine. We will be mainly focusing on a decision tree based model, and we will analyze, we will tweak certain hyperparameters of the decision tree model, and we'll also create some other models based on methods like logistic regression, random forest, support vector machine, and we can then compare how the accuracies of those models can be compared with the accuracy of the decision tree model. So moving on. So this data set was obtained from this particular source, and this data set contains 4,898 rows, and they are organized under 12 columns, and these are the 12 columns: fixed acidity, volatile acidity, citric acidity, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH value, sulfates, and finally, the quality value, the value that is given as a feedback by the consumer regarding the quality of the wine. So all of these parameters, except the final one, which is quality, they can be considered as continuous data. Continuous data. So there are fractional values, like there are decimal values. And the quality parameter, the value for the quality parameter can range from 3 to 9. 3 to 9, and the lower values correspond to lower quality wine, and higher values correspond to higher quality wine. So if we look at how balanced our data set is in terms of the quality, the value for the quality parameter. Now, as I told you, it ranges from 3 to 9. So how many samples are there corresponding to each and every quality value? So we can see the number of samples corresponding to lowest quality values and highest quality values are comparatively less when compared to quality values like 5, 6, and 7. So we can see this is not a balanced data set. So we are going to address this issue of unbalanced data set later in the study. So there is one particular important transformation that I did when analyzing this data set. So as we talked about before, the quality, the value for the quality parameter ranges from 3 to 9. So in order to simplify this model analysis, the values, the sample values or the quality values from 3 to 7, that means less than 7, that is 1, 2, 3, 4, 5, 6, they were given the value 0. 0 in the sense they indicate lower quality. And for values higher than 7, that is 8 and 9, okay, so 7, 8, and 9, they were considered as having higher quality. So 1, 2, 3, 4, 5, 6, they were assigned the value 0, that is lower quality. 7, 8, and 9, higher quality. So this quality column was readjusted. So there was a new column that was introduced, which contained only two values, 0 and 1. And the original column, which had values going from 3 to 9, was removed, and it was replaced with a new column having values only 0 and 1, 0 corresponding to lower quality and 1 corresponding to higher quality. And then I defined the feature matrix and the target classes. So the feature matrix contains all the features or the columns, not including the quality column. So these columns that are included in the feature matrix will act as deciding factors in determining the quality value. So they are included in the feature matrix. So using this Python code, I have defined the feature matrix as uppercase X, this variable. They will contain these columns. This X will contain these features, these feature values, and Y will contain the quality values. Then I split the data set into a training set and a testing set, and considering the total number of samples, out of the total number of samples, 30% of the samples will be included in the testing data set, and 70% will be included in the training set. So this is the code using which I made that split. So we can see how many samples are there in each of the two data sets. So in the training set, there are 3,428 samples, and in the testing set, there are 1,470 samples. So earlier also we had this problem of our data set being unbalanced. So now we are again going to look at the current status even after doing that transformation, where we change the quality column to where we added a new column, removing the previous column. Now in our new column, we only have zeros and ones. Now, if we look at how many rows correspond to 0 and how many rows correspond to 1, we can still see that the data set is not balanced. There are like currently in the unsplit data set, for the target variable having the value 1, there are 1,060, and the target variable having 0, there are 3,838 samples. So we can see that the high quality class is underrepresented. So when it is underrepresented, our model becomes biased. That means there is a higher tendency for the model to predict low quality and a lower tendency lower probability for the model to predict high quality. So now, according to this, we can see the imbalance ratio is somewhere around 3 to 1. Like there are around 3 times the number of samples of the having Y value in the number of samples in having 0. Okay, so like approximately 3 to 1 ratio. So even if we don't train the model, even if we just create a function, no matter what the input value is, it will only output 0. It will never output 1, it will only output 0. If we create such a function, even that model will have a accuracy roughly around 70%. That is because our data set contains a large number of samples corresponding to 0. So in order to remove this bias, I have used a method, an algorithm known as adaptive synthetic sampling to oversample the underrepresented high quality wine samples. So I have increased the number of high quality wine samples so that both low quality and high quality, the number of samples corresponding to both low quality and high quality, they are approximately equal. So after doing this resampling based on the adaptive synthetic sampling algorithm, we can see the number of samples corresponding to 0 and the number of samples corresponding to 1, they are roughly equal. Unlike the case which we had before, where there is an imbalance, now we can see that the data set is balanced. So for my further studies, I use this balanced data set. Now we come to the tweaking of the hyperparameters. So the first hyperparameter is the complexity pruning hyperparameter. Okay, complexity. So this particular parameter is given the name CCP alpha in Python. So what this particular parameter does is it is going to remove overfitting. Because if we give by default the value of CCP alpha is 0. So if we don't specify a value, it will be 0. Then after creating the model based on the training data, we will have a almost perfect decision tree model, but there will be a lot of overfitting, so that when it comes to making predictions on the unseen data, the model is not able to generalize. So it is going to have a lower testing accuracy. So in order to remove that, we can introduce a non-zero, a small non-zero value to CCP alpha. So what I have done is I have started from 0, and with increments of 0.01, I have tested values up to 0.25 for CCP alpha. Then I have, for each of these new values, I have reevaluated the model, calculated the accuracy, training accuracy and the testing accuracy, and I have plotted them, as you can see on the right hand side. From this plot, we can see the best, like sort of the best CCP alpha value that we can consider is somewhere around 0.05. So I have looked at the individual output values, and I have used 0.04 as the optimum value for CCP alpha. And the other parameter is the maximum depth. So if we don't we don't allocate a particular value for maximum depth, the decision tree model will keep on going and it will have a huge depth with a lot of overfitting. So we want to again minimize overfitting by defining a maximum depth beyond which the tree cannot go. So again, I am I'm trying a number of values for maximum, for the depth of the model, starting from 1, going all the way up to 15, and then again reevaluating the model, the accuracy, both the training accuracy and the testing accuracy, and I have plotted them against the value of maximum depth. So we can see here somewhere around starting from size maximum depth 13, we can see it is sort of trying to level off. So I'm using a maximum depth value of 30. Okay. So using these hyperparameters that we calculated, I'm creating the decision tree model. So this is 0.004 for CCP alpha and maximum depth 13 for maximum depth. So then I create the decision tree. My impurity criterion is the Gini value, and I can see you can see I have calculated the classification report, the confusion matrix. So the classification report gives an accuracy of 0.8 for this model, and you can see here the confusion matrix, and the main diagonal of the confusion matrix gives the true positives and the true negatives. And I have also saved the model so that I can use it later. And this is the corresponding decision tree. We can see this is a much simpler decision tree, but if we had not specified the CCP alpha value, it would have created a much more complex decision tree with a lot of overfitting. Here we can see that the classes have been split mainly based on the first split is based on alcohol level, whether it is less than or equal to 10.85, whether it's true or false. And then again, like on the left hand side, it's going to volatile acidity, with it's checking whether it's less than or equal to 0.203. Then if it is true, goes to left, and if it is false, goes to the right. So likewise, it is going to divide the samples. So this is the decision tree based on which this model will decide whether a particular sample is having low quality or high quality. So the other models that I have created, the random forest model. So I have created a random forest model having 100 trees, again based on the Gini criterion, using the same resampled X and Y data. So this one gives a higher accuracy, 0.85. And this is something that is to be expected, because this random forest model is having, in this particular case, 100 trees, whereas the decision tree model is only having 1 tree. And each of these trees will make predictions, and the final prediction will be based on the majority of the predictions given by each of the trees. So this is going, most of the time this is going to be giving a more accurate value than the random the decision tree model, which is based on only a single tree. Okay, so I'm saving this model as well, and 2 other models based on support vector machine and logistic regression. So they have actually given relatively lower accuracy, 0.71 for the support vector machine and 0.72 for the logistic regression. So these models also I'm saving because I'm going to use them for the software that I'm going to create and deploy, which I will talk about towards the end. So I have basically created 4 models: the decision tree model, random forest model, and there is a logistic regression model, and there is a model based on the support vector machine. So combining all these models, I have created the wine quality predictor app, which I have deployed on the Heroku platform, and it is available. You can access the app with this URL, and the corresponding source code and the supplementary files are made available at this location on GitHub. So I'm going to show you how the app that I have created, the web app, functions. So before that, the source code is and the supplementary file, they are available at this location in the GitHub. So in the GitHub, you can find the wine quality predictor, all the files, supplementary files, and the source code. So the source code is inside this Python file. You can see the source code here. And the app has been deployed to the Heroku platform. You can see here. So we just have to specify the values for each and every one of these parameters. So you can select a value by dragging the slider backward and forward. So there are minimum and maximum values already specified. So you cannot give a value outside those values. So any value between those values you can specify. You can select citric acid level likewise. So for this density and pH levels, you can just type out the pH, the value for the pH level and the density. For example, you can just, if you want to specify 3.54, you can just click it there. Likewise, and density, if you want 0.96, can do it like that. So here again, you can see it should be greater than or equal to 9.98. So you can specify something like, you want to specify something like 0.996, or I mean, doesn't matter. So here, although it shows 1, if you look here, you can see the value has been already taken as 0.996. So you can specify any value you want between those minimum and maximum values that have been specified. And then you can select a model. So we have created 4 models. So we can select any one of these models. So if you select, if you just first go with the decision tree, you can click on this predict button to get the prediction. So you can see it predicts as high quality. So it might be different for a different model. So if you select the random forest model and do the prediction based on the specified values, you can see it says low quality. So likewise, depending on the values you specify and the particular model that you select, the prediction can be different. So you can use this app to get the prediction on wine quality. So thank you very much for your attention. That concludes my presentation. Thank you.